Hi, welcome back to my class in Integral Calculus. Today we will do the continuation of integration by partial fraction, case 2. In partial fraction, case 1, the factors of the rational expression, which is the integrand in the given integral, has linear factors for the denominator of the rational expression, and the linear factors are all different or all unique. In the second case of integration by partial fraction, the factors of the denominator of the rational expression, which is the integrand of the given integral, are also linear factors, but some of them are not unique. Some of them are repeated twice, thrice, or more than thrice. So we take the first example. We have the integral of 5x cubed plus 7x minus 9 all over x plus 1 to the power 4. And we integrate with respect to x. In here, the integrand is the rational expression 5x cubed plus 7x minus 9 all over x plus 1 to the power 4. You can see that the denominator is already in factored form. If you expand this expression, it's a polynomial with 4 as the highest exponent of x. In factored form, we have x plus 1 to the power 4. And the x plus 1, the linear expression x plus 1, is a factor of that polynomial expression with 4 as the highest exponent of x. And we say that x plus 1 is a factor that is repeated 4 times. So the factor x plus 1 is not unique. Therefore, for evaluating this integral, we apply integration by partial fraction, case 2. Because, as I said, the linear factor x plus 1 is not unique. It is repeated 4 times. And again, by integration by partial fraction, we write this rational expression as a sum of partial fractions. The number of linear factors in both cases 1 and 2 of integration by partial fraction indicates the number of constants that we have to use. Here, the linear factor x plus 1 is repeated 4 times. That means we have to use 4 constants denoted by capital letters of the English alphabet. And for this example, I will use A, B, C, D. The denominators of these partial fractions are all the same with the factor x plus 1, but the exponent of x plus 1 from the first to the last partial fraction will be increasing. The exponent of x plus 1 will begin with 1, and then x plus 1 to the power 2, and then x plus 1 to the power 3, and the last denominator will be x plus 1 to the power 4. And this is the pattern that we use for integration by partial fraction, case 2. If the exponent of x plus 1 is 3, then we will have only up to this term, c over x plus 1 to the power 3. And as in case 1, the next step is to remove the denominator by multiplying both sides of this expression by LCD. And the LCD is x plus 1 to the power 4. If we multiply the left-hand side by x plus 1 to the power 4, x plus 1 to the power 4 here in the denominator will cancel out with x plus 1 to the power 4 in the numerator. And what will be left at the left-hand side is this trinomial 5x cubed plus 7x minus 9. We also multiply each term of the right-hand side by x plus 1 to the power 4. If we multiply x plus 1 to the power 4 by the first term, and we apply the property of exponents, for the first term we will get a multiplied by x plus 1 to the power 4 minus 1 is 3. The second term we also multiply by x plus 1 to the power 4. X plus 1 to the power 4 multiplied by b over x plus 1 to the power 2. And to divide x plus 1 to the power 4 by x plus 1 to the power 2, we apply property of exponent. And the second term simplifies to b multiplied by x plus 1 to the power 4 minus 2. The next term, c over x plus 1 to the power 3, we multiply by x plus 1 to the power 4. And again, we apply property of exponent. And the third term will be c multiplied by x plus 1 to the power 4 minus 3 or 1. And the third term is c multiplied by x plus 1 raised to 1. And finally, the last term, b over x plus 1 raised to 4 multiplied by x plus 1 raised to 4 simplifies to d because x plus 1 raised to 4 over x plus 1 raised to 4 is 1. Now we expand each term at the right-hand side. We expand x plus 1 raised to 3 and we apply one of the special product rules for the cube of a sum. The left-hand side is the same, 5x cubed plus 7x minus 9. This symbol is read as identically equal to. And we recall from your algebra this is one of the special product rules from algebra. The cube of a sum, the sum of a plus a and b. So a plus b to the power 3 is equal to a cubed plus 3a squared b plus 3a times b squared plus b raised to 3. Where in our example, a is x and b is 1. So in this special product rule, replace a with x and b with 1. And the expansion of x plus 1 raised to 3 is x cubed plus 3 x squared plus 3x because b is 1 plus b cubed, b is 1, 1 raised to 3 is 1. And for the expansion of x plus 1 raised to 2, we also apply property, one of the special product rules for the square of a sum. From algebra, the square of a sum of a and b, or a plus b squared is equal to the square of a plus twice the product of the two terms a and b plus the square of the second term. And if you apply the special product rule to our example, a is x and b is 1. So the expansion of x plus 1 is square is x squared plus 2 multiplied by x plus 1. And here we apply the property of multiplication over addition, the distributive property. We multiply x and 1 by c, and we get cx plus c plus d. Now, after the expansion, we equate the coefficients of the variables at the right-hand side with the coefficient of the variable at the left-hand side, with the variable having the same exponent at the left and at the right. And we start with x cubed. At the right-hand side, the coefficient of x cubed will be a. If you multiply a by x cubed, you get ax cubed. And this is the only term with x cubed. So the coefficient of x cubed is a at the right. And we equate a to the coefficient of x cubed at the left. At the left, the coefficient of x cubed is 5. Hence, a is equal to 5. Thus, we now know that one of the four constants ABCD, a is 5. Next, we equate the coefficient of x squared at the right-hand side. If you multiply 3x squared by a multiplied by 3x squared, you get 3ax squared. And the coefficient of x squared is 3a for this term. And here, if you multiply x squared by b, you get bx squared. And so the coefficient of x squared for this term is b. And the rest of the terms have no x squared. So the coefficient of x squared, if you factor out x squared as common factor, is 3a plus b. And we equate this coefficient of x squared at the right-hand side with coefficient of x squared at the left-hand side. But the left-hand side has no x squared. If we add a term, x squared, to the left-hand side, the coefficient of x squared should be 0. You can always add a term with x squared, but its coefficient should be 0, so that the left-hand side will not change. Therefore, this coefficient of x squared at the right-hand side, we equate to 0. Because, as I said, if we will add a term with x squared, its coefficient must be 0. But we already know the value of a. A is equal to 5. Therefore, we can solve for b from this equation by substituting the value of a, which is 5. And a is 5 multiplied by 3 is 15. And transpose that to the right-hand side so that we will only have b at the left-hand side. Therefore, the value of b is negative 15. Now we consider the coefficient of x at the right hand side. If we multiply 3x by a, you will get 3ax, and the coefficient of x is 3a. And we should add that to the coefficient of x for this term. If you multiply 2x by b, you get 2bx. In here we have 3ax, and here we have 2bx, and here we have cx. Therefore, we have three terms with x. 3ax plus 2bx plus cx. And if you factor out x as the common factor, the coefficient of x will be 3a plus 2b plus c. A plus 2b plus c. And we equate this coefficient of x at the right hand side to the coefficient of x at the left hand side. At the left hand side we have 7x, and coefficient of x is 7. So we equate 7 to 3a plus 2b plus c. And from this equation, we can solve for c because we know the value of a, it's 5. We know the value of b, negative 15. So we simply transpose 3a to the right hand side and 2b to the left hand side. Sorry, to the right hand side, we transpose 3a and 2b to the right hand side. And we get c equals 7 minus 3a minus 2b. And we substitute the values of a and b. We have 7 minus 3 multiplied by a is 5. Minus 2 multiplied by b, negative 15. And we simplify the right hand side. We have 7 minus 3 times 5 is minus 15. And negative is positive, and 2 times 15 is 30. Therefore, we have 7 minus 15 plus 30. And the value of c is 22. We have 30 minus 15 is 15, plus 7 is 22. Or 7 minus 15 is minus 8, and minus 8 plus 30 is 22. Finally, we equate the constant term at the right hand side with the constant term at the left hand side, which is negative 9. At the right hand side, the constant term consists of a multiplied by 1 is a, plus b multiplied by 1 is b. So we now have a plus b and plus c plus d. Thus, the constant term at the right hand side is the sum of a plus b plus c plus d. And we equate this constant term at the right with the constant term at the left, negative 9. And from this equation, we can readily solve for D because we know the values of A, B, C. So D is equal to negative 9 minus A, transpose A to the right, minus A, minus B if you transpose B to the right, and minus C by transposing C to the right. We substitute now the values of A, B, C. A is 5. We have minus 9 minus 5. Minus B. Our value of B is negative 15. That's minus times negative 15. And minus C, our C is 22. Thus, our value of B is negative 22 minus 15, that's negative 7. Or negative times negative is positive. 15 minus 22 is negative 7. Minus 5, that's negative 12. And minus 9, that's negative 21. We check the value of B. We have minus 9 minus 5 is negative 14. Plus 15 is 1. 1 minus 22 is negative 21. Now we have all the values of the constants A, B, C, D, and we substitute them into this expression, and we will change this symbol identically equal to equal to. And we integrate both sides with respect to x. Substitute the values of A, B, C, D. At the left hand side, we still have 5x cubed plus 7x minus 9 all over x plus 1 raised to 4. And we now change this symbol for identically equal to inequality sign. And the value of A is 5 over x plus 1 raised to 1. Plus B, the value of B is negative 15. And multiplied by positive, that's negative. Over x plus 1 raised to 2. Plus C, the value of C is positive 22. So plus 22 over x plus 1 to the power 3. And the last term is plus D, but D is negative 21. Negative 21 multiplied by positive is negative 21 over x plus 1 raised to 4. After the substitution, we now integrate both sides of this equation with respect to x. For the first term, we apply the integration rule for du over u, which is ln of u. For the second, the third, and the last term, we apply the power rule. And to apply the power rule, we let x plus 1 be equal to u. And we differentiate both sides. Derivative of u is 1 multiplied by du equals derivative of x is 1 multiplied by dx or dx. Hence, differentiating both sides, we get du is equal to dx. At the right hand side, we replace x plus 1 with u, and we replace dx with du. And the left hand side remains the same because this is the given integral that we want to evaluate. The right hand side now is 5 over x plus 1 is u, and u raised to 1 is u. Hence, the first term at the right hand side is simply 5 over u. The second term is minus 15 over x plus 1 is u, or minus 15 over u is squared. And the third term is 22 over x plus 1 is u, u to the power 3. And the last term is minus 21 over x plus 1 is u to the power 4, or minus 21 over u raised to 4. And we replace dx with du. To the right hand side, we apply integration rule that says the integral of a sum or difference of two functions is equal to the sum or difference of the integrals of the two functions. Hence, to integrate the sum and difference, we integrate each term with respect to u. And the first term is the integral of 5 over u with respect to u. Minus the integral of 15 over u squared. And 15 is a constant. We integrate 15 over u squared with respect to u. The next term is the integral of 22 over u cubed with respect to u. Minus the integral of 21 over u raised to 4 with respect to u. To the first term, we apply the integration rule for du over u, which is ln u. And to these last three terms, we apply the power rule. And to apply the power rule, we bring the denominators to the numerator. And we apply another integration rule that says the integral of a constant times the function is equal to the constant times the integral of the function. Therefore, for each of these four terms, we bring out the constant outside of the integral sign. And the first term becomes 5 times integral of du over u. The second term is minus 15 times the integral of du and we bring u squared to the numerator to apply the power rule. And by property of exponent, if you bring this to the numerator, you take the opposite sign of the exponent of u. So u squared, if you bring that to the numerator, becomes u to the negative 2 multiplied by du. The next term is 22 plus the integral of u to the negative 3 with respect to u. You bring u cubed to the numerator and you take the opposite sign of the exponent of u, which is positive 3, and it becomes negative 3. And the last term is 21 times the integral of u to the negative 4, because we brought u raised to 4 to the numerator and we apply the property of exponents, so we take the opposite sign of the exponent of u in the denominator, it becomes negative 4. And we integrate u to the negative 4 with respect to u. Now we are ready to integrate all these terms. Here, by integration rule, for the integral of du over u is equal to ln of u. And we put the absolute value sign because we want to make sure that u is positive, because ln of negative is not defined. Minus 15. We apply the power rule to this second term. The exponent is negative 2 plus 1 is u raised to negative 1. And the exponent negative 1 we also use as divisor, divide by negative 1. That's according to the power rule. The next term, 22, we apply again the power rule to the integral of u to the negative 3. We add 1 to negative 3, that's negative 2. And we divide this term by negative 2. Hence, the next term is plus 22. Plus 22 times the integral of u to the negative 3. Negative 3 plus 1 is negative 2. And we use that answer as divisor, divide by negative 2. And for the last term, we have negative 21. Again, by power rule, we add 1 to negative 4. Negative 4 plus 1 is negative 3. U to the negative 3. And this exponent of u negative 3 we also use as divisor. We divide by negative 3. Since we have integrated all the terms, we now write the constant of integration c. And now we have to bring back the answer to the original variable x. The first term is 5 times ln of u, and u is x plus 1. The next term is negative times negative is positive 15. In the final answer, we remove the negative exponents. So if you bring u to the negative 1 to the denominator, you take again the opposite sign of u, which is negative 1. You bring u to the negative 1 to the denominator, you get 15 over u raised to 1, or 15 over u. But u is x plus 1. Hence, the second term minus 15 divided by negative 1 is positive 15. And u to the negative 1 is over u, and u is x plus 1. The next term is positive 22 divided by negative 2, that's negative 11. And u to the negative 2, we bring down to the denominator and we take the opposite sign of u, which is negative 2. And we get 11 over u is squared. But u is x plus 1. So u squared is x plus 1 squared. The next term is negative 21 divided by negative 3, that's positive 7. And again, we bring u to the negative 3 to the denominator because we want to get rid of negative exponents in the final answer. So if you bring u to the negative 3 to the denominator, it becomes u to the positive 3, or u cubed. Negative 21 divided by negative 3 is positive 7. U to the negative 3, you bring down to the denominator, you get over u to the power 3. But u is x plus 1. So this term is 7 over x plus 1 cubed. And this is the integral of the given integral of 5x cubed plus 7x minus 9 all over x plus 1 raised to the power 4 with respect to x. And this completes the solution of our example 1. For our next example, we apply again the integration by partial fraction case 2, where the factors of the denominator of the rational expression in the given integral, which is the integrand of the given integral, are linear factors, but some of the factors are repeated. But in this example, I will show you another way of finding the values of the constants instead of using expansion and special product rules. Because if you use the expansion method and the special product rules, the solution could be lengthy. But in this another way of finding the values of the constants, you will save a lot of time by not using expansion and the special product rules. So consider the following problem. We have the integral of 2x squared minus 3 all over x minus 1 cubed multiplied by x plus 1. And we want to integrate and want to evaluate this integral with respect to x. And again, this is the given rational expression, which is the integrand of this given integral. And the denominator is already in factored form. But if it is not in factored form, before you proceed with the process of integrating by partial fraction, you have to factor out the denominator. But in this example, the denominator is already in factored form. But the factor, the linear factor x minus 1 is not unique because its exponent is 3, which means that the factor x minus 1 is repeated 3 times. And there is another factor, x plus 1, which is unique because its exponent is 1, which means that it is not repeated. Still, this is integration by partial fraction case 2 because one of the factors x minus 1 is repeated 3 times as indicated by the exponent 3. So we write this rational expression as identically equal to the sum of partial fractions. And in that sum of partial fractions, we will use how many constants? We will use 4 constants because x minus 1 is repeated 3 times, That means we have to use three constants, and there is a second factor which is unique x plus 1, and for this unique linear factor we use another one constant. So for the repeated linear factors x minus 1 we use three constants, and for this unique linear factor x plus 1 we use one constant, or a total of four constants. Again, I will use the first four capital letters of the English alphabet as the constants A, B, C, D. And for the denominator, we start with the linear factor x minus 1. The factor x minus 1 will be treated as denominator of the first three terms with increasing power, beginning with x minus 1 raised to 1, and then x minus 1 raised to 2, and then x minus 1 raised to 3. And for the unique factor x plus 1, we simply write b over x plus 1 raised to 1, or x plus 1. Now, you may choose to write x plus 1 as denominator of a, and that is also correct. So if you write x plus 1 as denominator of a, you will get the first term a over x plus 1. The second term will be b over x minus 1 raised to 1. The next term will be c over x minus 1 squared. And the last term will be d over x minus 1 raised to 3. And that is also correct. And you should get the same constants for the numerators. Now, the next step in what we usually do is for the second step, for the next step, we usually eliminate the denominators by multiplying both sides of this expression by the LCD. And we do that. The LCD will be x minus 1 cubed multiplied by x plus 1. If you multiply the left-hand side by x minus 1 cubed times x plus 1, that will cancel out with the denominator of at the left-hand side, x minus 1 cubed times x plus 1. And what will be left at the left-hand side is 2x squared minus 3. And this expression is identically equal to a multiplied by x minus 1 cubed times x plus 1 over x minus 1. And this x minus 1 cubed over x minus 1 simplifies to, by property of exponent, common base is x minus 1, raised to 3, minus 1 here is 2. So for the first term, we get a times x minus 1 squared times x plus 1. And the next term, b over x minus 2 squared, we multiply by x minus 1 cubed, multiplied by x plus 1. And we simplify x minus 1 cubed over x minus 1 squared by property of exponent. The common base is x minus 1 to the power 3 minus 2 in the denominator is 1. Hence, the next term is b times x minus 1 raised to 1 times x plus 1. The next term is c over x minus 1 cube multiplied by x minus 1 cube times x plus 1. X minus 1 cube over x minus 1 cube is 1. Or we simply cancel this out and we get c times x plus 1. And the last term will be d over x plus 1 multiplied by x minus 1 cube times x plus 1. And x plus 1 over x plus 1 will cancel out because it's equal to 1. And the last term is d multiplied by x minus 1 cube. After eliminating the denominators, the next step that we usually do is we expand. By using the special product rule, the expressions at the right-hand side. We usually expand x minus 1 is squared by using special product rule for the square of difference. And we expand the cube of x minus 1, the cube of the difference x and minus and 1, using the special product rule for the cube of difference. And we also expand this. This is the product of a sum or difference, another special product rule. But this time we will not expand. To find out the values of the constants, you find the values of x that will make the denominator, this denominator 0. And this denominator will be 0 if x minus 1 is equal to 0 and x plus 1 is equal to 0. If x minus 1 is 0, then this denominator will be 0. If x plus 1 is equal to 0, then the denominator will be 0. Therefore, to find the values of x that will make this denominator 0, equate each linear factor to 0. The first linear factor is x minus 1. You equate that to 0. If x minus 1 is 0, then from this equation you can solve for x. You transpose negative 1 to the right hand side and you get x is equal to 1. Now substitute this value of x to this expression. X is equal to 1. This becomes 2 multiplied by 1 squared minus 3. Or that's 2 minus 3 is equal to negative 1. And we equate negative 1 to the value of the right hand side when x is 1. When x is 1, this will be 0. So this term will be 0. When x is 1, this term will be 0. Because x is 1, 1 minus 1 is 0. If x is 1, this term will not be 0. Because you have x plus 1 and x is 1. So you get 2 multiplied by c is 2c. And when x is 1, the last term is 0. Because x minus 1 is 0 to the power 3 is 0. Multiplied by d is 0. Therefore, we simply get this equation, negative 1 equals 2c, from which we can solve for c by dividing both sides by 2. And negative 1 equals 2c implies c is equal to negative 1/2. So we have found one value of the 4 constants, the value of c. Now, another value of x that will make this denominator 0 is obtained when you set the second linear factor x plus 1 to 0. If x plus 1 is equal to 0, this denominator will be 0. And from this equation, you can solve for x by transposing positive 1 to the right hand side and you get x equals negative 1. This is another value of x that will make this denominator 0. Because if x equals negative 1 plus 1 is 0, multiplied by this is 0. And we substitute this value of x again to this expression at the left and equate that value at the left with the value of this expression when x equals negative 1. When x equals negative 1, the left hand side is 2 times negative 1 squared minus 3. Negative 1 squared is positive 1 multiplied by 2 is 2 minus 3 is negative 1. And we equate this value at the left hand side when x equals negative 1 to the value that we will get for the right hand side when x equals negative 1. When x equals negative 1, this will be 0. Multiplied by x minus 1 squared multiplied by a is 0. When x equals negative 1, negative 1 plus 1 is 0, multiplied by x minus 1 is 0, multiplied by b is 0. When x is minus 1, then this x plus 1 will be 0 because minus 1 plus 1 is 0, multiplied by c is 0. But the last term, if x is minus 1, you have minus 1 is negative 2, and negative 2 to the power 3 is negative 8. Multiplied by b equals negative 8. And from this equation, negative 1 equals negative 8, we can solve for d by dividing both sides by negative 8. Minus 1 equals negative 8d implies that d equals positive 1 over 8. Negative 1 divided by negative 8 is positive 1 over 8. Now we have found the values of two constants, c and d. The only two constants to be found that we have to find are a and b. You can see that a, if you expand x minus 1 squared times x plus 1, you will get a polynomial expression, a cubic expression with x and 3 as its highest exponent. And the exponent, the coefficient of x cubed in this first term, if you multiply x minus 1 squared, you will get here x squared as the first term. Because the square of x minus 1 is by special product rule is x squared minus 2x plus 1. So the first term in the expansion of x minus 1 squared is x squared. And you multiply that by x, you get x cubed. And you multiply that by a, you get ax cubed. So the first term in this first term, if you expand this, is ax cubed. And there is another term with x cubed if you expand x minus 1 to the power 3 by special product rule for the cube of a difference. The first term of x minus 1 cubed is x cubed. Multiply by b, that's bx cubed. And we collect the terms with x cubed. The first term with x cubed is ax cubed. The next is plus bx cubed. And we factor out x cubed, we get a plus b. This coefficient of x cubed at the right hand side, we equate to the coefficient of x cubed at the left hand side. But you can see the left hand side has no x cubed, but you can always add a term with x cubed to the left hand side, but the coefficient should be 0. Therefore, a plus b, the coefficient of x cubed at the right hand side, we equate to 0. Because as I said, there is no x cubed term at the left hand side, but you can always add x cubed with coefficient of 0. Or you add 0 plus 0 x cubed. Therefore, the coefficient of x cubed at the left hand side is 0. And we already have the value of d, 1 over 8. If we substitute the value of d here, That means A is equal to negative D, but D is 1 over 8. Therefore, this A plus D equals 0 implies A equals negative 1 over 8. From this equation, we transpose positive D to the right-hand side, we get minus D. A equals minus D, but D is 1 over 8. Therefore, A equals negative 1 over 8. Now, the only constant that we have to find now is B. And to find B, we get the coefficient of x squared, because if we expand x minus 1 and x plus 2, this is the product of a sum or difference. X minus 1 times x plus 1 is x squared minus 1. And that x squared multiplied by b, we get bx squared. And also here we will get a term with x squared. We have x minus 1 squared is x squared minus 2x x squared minus 2x plus 1 is the expansion of x minus 1 squared multiplied by x plus 1. If you distribute x, you get x cubed minus 2x squared. We still have a, that's minus 2 ax squared plus ax squared. X squared minus 2x plus 1 multiplied by x plus 1. We are interested with the coefficient of x squared, so we only get the terms with x squared. We have x multiplied by minus 2x is minus 2x squared multiplied by a minus 2ax squared. And 1 multiplied by x squared is x squared multiplied by a is plus ax squared. So the coefficient of x squared here is minus 2a, or this simplifies to minus 2ax squared plus ax squared is negative a. Negative ax squared. And we add this to the coefficient of x squared in the other terms. Here we have x minus 1 multiplied by x plus 1 by special product rule for the product of a sum or difference is x squared minus 1. And x squared multiplied by b is bx squared. So for this term, you will get bx squared for the first term, we have minus ax squared. For this term, we get bx squared. For this term, we will not get a term with x squared. For the last term, we will get a term with x squared if you expand x minus 1 to the power 3 using the special product rule for the cube of a difference. And the expansion of this is x squared minus Again, from algebra, the expansion of the cube of a difference a minus b cube is equal to a cube minus 3a squared b plus 3ab squared minus b cubed, where a in our example is x and b is 1. Hence, the expansion of x minus 1 cubed by this special product rule is x cubed minus 3x squared plus 3x minus 1. And this is multiplied by d. If you multiply this polynomial by d, you will get d multiplied by minus 3x squared. Hence, for the last term, the term with x squared is minus 3dx squared. Now we collect all the coefficients of x squared. For this term, coefficient of x squared is minus a. For this term, the coefficient of x squared is b plus b. And this term has no term with x squared. And for the last term, the coefficient of x squared will be minus 3. Minus 3d. We have minus 3x squared multiplied by d, that's minus 3dx squared. And the coefficient of x squared is minus 3d. This coefficient of x squared, at the right hand side, we equate to the coefficient of x squared at the left hand side, which is 2. But we already have the value of a. A is negative 1 over 8. And we already have the value of d. D is positive 1 over 8. From this equation, we solve for b. b equals 2. Transpose minus a to the right hand side plus a. And negative 3d transpose to the right hand side, we get plus 3d. We now substitute the values of a and d to solve for the value of b. Where a we obtained earlier is equal to negative 1 over 8 and b is equal to positive 1 over 8. Thus we write b equals 2 plus a is negative 1 over 8 plus 3 multiplied by d. d is positive 1 over 8. And the last two fractions have common denominator of 8. And we want the first term to have a denominator of 8. So we multiply 2 by 8 over 8 so that 8 is the common denominator. Multiplying 2 by 8, we get 16. And positive times negative is negative 1. So we have 16 minus 1 is 15. Plus 3 multiplied by 1 is 3. We have 2 multiplied by 8 is 16 minus 1 plus 3 is 18 over 8. 8 being the common denominator. And 18 over 8 can still be reduced to lowest terms by dividing 18 and 8 by the highest common factor, which is 2. 18 divided by 2 is 9. And 8 divided by 2 is 4. Thus, the value of the constant b is 9 over 4. Now, we have found all the constants a, b, c, and d, and we substitute them to this expression. And when we substitute a, b, c, d, we change this symbol for identically equal to equality. But before we do that, we check the value of b by getting another equation that contains b, the unknown b. This equation we obtain by taking the coefficients of x squared and equating the coefficient of x squared at the right hand side with the coefficient of x squared at the left, which is 2. Now we get an equation from the coefficient of using the constant terms at the right hand side. We will get an equation containing b using the constant terms. In the first term, if you expand this, you will get x squared minus 2x plus 1. And the constant term is 1 multiplied by 1 and multiplied by a, you get a. Thus, the constant term for this term is a. For the second term, if you multiply x minus 1 by x plus 1 by special product rule for the product of a sum and difference, you will get x squared minus 1. And minus 1 is a constant multiplied by b, you get minus b. Hence, the constant term for this first term, if you multiply x minus 1 squared by x plus 1 is a. And for this term, the constant term is minus b. And here, if you multiply c by 1, you get c. So for this third term, the constant term is c. Earlier, we write the expansion of x minus 1 cube, and we see that the last term in the expansion of x minus 1 cube is negative 1. And negative 1 multiplied by d, you get negative d. And we add all the constants at the right hand side. For the first term, the constant term is a. For the second term, the constant term is negative b. For this term, the constant term is c multiplied by 1 is plus c. And for the last term, the constant term is minus d because the constant term in the expansion of x minus 1 cube is negative 1 multiplied by d minus d. And this constant at the right hand side, you equate to the constant at the left hand side, which is negative 3. And we already have the values of a, negative 1 over 8. The value of c is negative 1/2. And the value of d is 1 over 8. And we would like to check if the value of b from this equation is 9 over 4. And from this equation, we solve for b. And it's easier if we transpose negative b to the right hand side and we transpose negative 3 to the left hand side. If we do that, we transpose negative b to the right hand side, we get positive b. At the left, we have a plus c minus d. And negative 3, we transpose to the left, we get plus 3. Now we substitute the values of a, c, and d. b equals a, negative 1 over 8. Plus c, C is negative 1/2. Plus C is negative 1/2 minus D is 1/8 and plus 3. Now we want a common denominator of 8. And here the LCD between 8 and 2 is 8. The lowest number that can be divided by 8 and 2, and denominator of 3 here is 1. The lowest number that can be divided by all the denominators, 8, 2, and 1 is 8. So we want a common denominator of 8. The first term has a denominator of 8. The second term, the denominator is 2, and we want the denominator to be 8. So we multiply the numerator and denominator by 4. And you get negative 4/8. This term, the denominator is 8. And the last term, the denominator is 1. And we want to have 8 in the denominator. So we multiply 3 by 8/8. We get negative 1. Multiply this by minus 4. Negative 4. We have minus 1. Multiply by minus 4. Positive times negative is negative. Multiply by 4 minus 4. And here we have minus 1. And here we have 3. We multiply 3 by 8/8. We get 3 multiplied by 8 is 24. And we have minus 1, minus 4, minus 1 is minus 6. And minus 6 plus 24 is 18. Over 8. And 18/8 is 9 to the lowest terms is 9/4 by dividing 18 by 2, 9, and 8 divided by 2 is 4. So there are two ways by which you can get the value of B. Either you use the coefficients of the terms with x squared from the right hand side and equate that to the coefficient of x squared 2 at the left hand side, or you use the constant terms at the right hand side, which is a minus b plus c minus d, and equate this constant term to the constant term at the left hand side, which is minus 3. We now substitute the values of a, B, C, and D to this expression, and we change this identically equal to symbol to equality. And after the substitution of the constants, we integrate both sides with respect to x. The left hand side is the same, the rational expression 2x squared minus 3 over x minus 1 cubed multiplied by x plus 1. And we change this symbol for identically equal to equality. And we substitute the value of a. A is negative 1/8 over x minus 1 plus b. B is 9/4 over x minus 1 is square plus c, and the value of c is negative 1/2 over x minus 1 cubed. And the last term is plus d, where d is positive 1/8 over x plus 1. And we now integrate both sides with respect to x. The left-hand side is actually the given that we are asked to evaluate. For the right-hand side, we apply the integration rules for the integral of a sum and the integral of a constant times the function. We integrate each of these terms with respect to x, and we take the constant outside of the integral sign. Hence, the right-hand side is now equal to negative 1 over 8, a constant, multiplied by the integral of 1 over x minus 1 with respect to x. Plus the constant 9 over 4 multiplied by the integral of dx over x minus 1 squared. The next term is positive times negative 1/2 is negative 1/2. Times the integral of dx over x minus 1 cubed. And the last term is 1 over 8 times the integral of dx over x plus 1. To integrate each term at the right hand side, you may let u be equal to x minus 1. And if you differentiate both sides, you get du over dx. For the last term, for the first three terms, you let u equals x minus 1. And differentiating both sides, the left hand side with respect to u, you get du equals the derivative of x minus 1 with respect to x is dx. For the last term, we will use this substitution for the first, second, and third terms. But for the last term, we let u equals x plus 1. And again, we differentiate both sides. Derivative of u at the left-hand side is du. And derivative of x plus 1 with respect to x is dx. Derivative of x is 1 multiplied by dx. The right hand side now is negative 1 over 8 multiplied by the integral of dx. Dx is du. X minus 1 we let to be equal to u plus 9 over 4 multiplied by the integral of dx. Dx is du. Again, x minus 1 is u to the power 2 or u squared. The next term is negative 1/2 times the integral of dx. Dx is du. And x minus 1 is u to the power 3. And for the last term, our x plus 1 is u. So the last term is plus 1 over 8 times the integral of dx. dx is du over x plus 1. X plus 1 is u. For the first and last terms, we use the integration rule for integral of du over u, which is equal to ln u. For the middle terms, the second and the third terms, we apply the power rule. So the first term is equal to negative 1 over 8. And integral of du over u is equal to ln u. Plus 9 over 4. We bring u squared to the numerator before we apply the power rule, so we can see the exponent of u. If you bring u squared to the numerator, you apply property of exponent. But that says if you bring a term, an expression, an exponential form expression from the denominator to the numerator, or from the numerator to the denominator, you take the opposite sign of the exponent. So we bring u squared to the numerator, we take the opposite sign of 2, and we get u to the negative 2. For this term, we also bring u cubed to the numerator. So we take the opposite sign of positive 3, and we get u to the negative 3. And we integrate that with respect to u. And the last term is 1 over 8 multiplied by the integral of du over u equals ln u, where u in the last term is equal to x plus 1. Now we integrate this integral of u to the negative 2 with respect to u by power rule, and also the integral of u to the negative 3 with respect to u is evaluated by power rule. In the second term, in the power rule, n equals negative 2. In this third term, in the power rule, n is negative 3. We have negative 1 over 8. Multiplied by ln of u. And for the first term, our u is x minus 1. Plus 9 over 4. Multiplied by integral of u to the negative 2. Negative 2 plus 1 is negative 1. And the answer negative 1 we use as divisor. Minus 1 half. Minus 1 half times the integral of u to the negative 3 by power rule. We have negative 3 plus 1 is negative 2. And we use negative 2 as a divisor. And the last term is 1 over 8 times ln of u, where u is equal to x plus 1. Since we have integrated all the terms, we now write the constant of integration at the last term. And we bring back the answer to the original variable x for the second and the third term, where u is equal to x minus 1. Here we have positive times negative is negative 9. And we do not want negative exponents in the final answer, so we bring u to the negative 1 in the denominator. In the denominator, we have 4. If we bring u to the negative 1 in the denominator, that will be u to the positive 1 or u multiplied by 4. But u, so we get 4u, negative 9 over 4u, but u equals x minus 1. Negative times negative is positive. And we bring u to the negative 2 in the denominator. In the denominator, we already have 2 times 2 is 4. And so the numerator will only be 1. 1 over 2 times 2 is 4. And 4 is multiplied by u squared. If you bring u to the negative 2 in the denominator, it becomes u to the positive 2. And so in the denominator, we have 4 times u squared. But u is equal to x minus 1. Hence, this term is 1 over 4 times x minus 1 squared. And the last term is the same, plus 1 over 8 multiplied by ln of x plus 1 plus c. And this is the solution, or the integral of 2x squared minus 3 over x minus 1 cubed multiplied by x plus 1 with respect to x. And this completes the solution. For your exercise and assignment, please try the following problems. Evaluate number 1, integral of x plus 5 over x plus 3 squared with respect to x. Number 2, integral of x squared minus 2x plus 1 all over x squared multiplied by x minus 2 squared with respect to x. In both of these problems, you will use integration by partial fraction, case 2. If you have question about the lesson today, please ask your question in the comments below. But don't forget to subscribe to my YouTube channel, Art Calisan, the channel of learning and leisure. Thank you for joining me in my class today in Integral Calculus.